To continue our discussion about heat transfer by conduction, we are now going to talk about conduction in plane walls that is in series. As you can see on this figure here, meron tayong tatlong walls that is arranged in series. In our previous lesson, we discussed about conduction through a flat wall. So we are only considering one flat wall in our previous discussion. However, before we proceed with plane walls in series, let us first again have a quick review in our previous lesson about conduction through a flat wall. So let us identify again yung mga variables na ginagamit natin in calculating for our heat transfer in conduction. No? So let's say our heat is flowing on this direction. So one parameter that we are considering is our temperature. So we are noting the temperature in the outside surface and the temperature on the inside surface. Aside from that, we are also taking note the thickness of our wall, and we know that as delta X. And of course, we need to get the thermal conductivity of our wall. So we are taking the K, which is our thermal conductivity of our wall. And another is yung area ng ating wall. Okay? So we are taking note of that. And because of that, we will be able to calculate for the heat flow. Okay, so this is basically the parameters that we are using in calculating for conduction. Now, using Fourier's law, we learned that we have Q, okay, from x1 to x2 dx over area. This is equal to negative K over T1, T2, and dt. Okay? So, we are not going through in detail ng ating Fourier's equation, but we are just going to show you what we'll get in integrating both sides of our equation. Ano? But if you want to learn more about this, you can check our previous video about conduction. Okay, so let's have our area as our average area A prime. And we will take it out from our equation. So we will have Q over our average area. Okay, the integral of dx from x1 to x2. And we have our average thermal conductivity, which is K bar. Okay, and we have the integral of dt from T1 or from T2 to T1, right? So, sorry, this is T2 to T1. Okay, so integrating both sides, we will have Q over A bar, then x2 minus x1, which is our delta X, our thickness, and this is equal to K bar. Okay, then T1 minus T2, which is our delta T. Okay, so when we are solving for Q, we will have our K bar over A bar delta T over delta X. Okay, so this is our formula according to Fourier's law, right? So let me box this. However, kung naaalala ninyo, we discussed that we can arrange this in a different form, right? We can also write this as Q is equal to delta T. Then I'm going to put this K and A at the denominator. Okay, so we will have delta X over KA. Okay, this is K bar and A bar. Okay, and if you remember, we mentioned on our previous lecture that this whole thing in our denominator is our resistance R. And I told you this will be important kapag nag-usap na tayo about heat transfer by conduction in series, di ba? So, if that is our resistance, we can express our Q as delta T over R. Okay, so this is what we have for conduction, using Fourier's law. Okay, ginawa natin yan para mas mapadali yung ating pag-a-analyze ng ating heat transfer by conduction dito. This is because it is just the same. Kaya lang nagkaroon tayo dito ng tatlong flat wall na magkakadikit, no? Bago tayo makarating sa ating outside surface. So, now let us analyze this. Let's say our heat is flowing on this direction. Okay, so we have Q, Q. So, one thing that we need to take note is that at steady state, our heat flow Q must be the same on each layer. So, our Q will be the same at any stage here, no? On every layer. Okay, so, yan tatandaan natin. That is why we have here Q, and dito naman Q rin. So, the heat entering is the same as heat leaving, right? So, we have 3 blocks here, and we have to say that they are of different materials, no? So, we have here block 1, block 2, and block 3. Okay, or wall 1, wall 2, and wall 3. So, identify natin uli yung mga parameters na kailangan natin. So, una, syempre, yung temperature. So, from this surface, which is from inside of our furnace, for example, so, we have here our temperature 1. And leaving, of course, dahil mas mababa yung ating temperature, so let us put it right here. And this is our T2. Okay, so yan yung mga kailangan nating parameters. Tulad nito, meron tayong T1 pumapasok at meron tayong T2 na lumalabas. But now, it will be different case dahil meron tayong tatlong walls. So, what will be the temperature once it comes out on our first wall? So, let's say that is TA, which is the temperature after it leaves the first wall. Then, the next wall, it will leave at TB. Okay, and then finally, we have our temperature 2. Okay, so yan yung mga kailangan natin, no? Next is, what will be the thickness of our walls? Okay, so let's say this is our delta x1, delta x2, and delta x3. So these are the thicknesses, no? Thickness of our wall 1, thickness of our wall 2, and thickness of our wall 3. So, dahil magkakaiba ang ating mga materials dito, no? Yung mga walls natin magkakaiba. So, therefore, magkakaiba rin ang ating thermal conductivity. So, we have here the thermal conductivity of our wall 1. So, okay, so let me say this is K1. Thermal conductivity of our wall 2, which is K2. And thermal conductivity of our wall 3, which is K3. Okay? So, yan yung mga parameters na kailangan natin katulad ng ginamit natin dito. And of course, yung area, no? So, in this example, pare-pareho yung ating surface area, but it can be different, no? So, we have here area 1, we have area 2, and we have area 3. Okay? So, yan yung mga parameters na kailangan natin. So, we said that at steady state, our heat flow Q must be the same on each layer. So, our Q from 1 to 2, okay, from this point to this point, point 1 to point 2, okay, should be equal to the heat, okay, that is leaving wall 1, that is leaving wall 2, and leaving wall 3. So, our Q will be the same, okay, on each layer. So, bawat layer natin, pare-pareho lang yung Q natin. So, what do we mean by that? So, our heat here on our first wall, which is Q1, is also equal to Q2, and this is equal to Q3. Okay, because our heat is the same on every layer at steady state, diba? So, this is what we need to take note. Ito yung pinaka-importanting concept na dapat natin maintindihan when we are talking about conduction in plane walls in series. Okay, the same ang ating heat flow on each layer. So, how does this affect? Okay? So, alam natin, based dito sa calculation natin, our Q is equal to delta T over the resistance. Okay? So, if you're talking about our heat from point 1 to point 2, that means from this point to this point, lahat na yan overall. So, we can say that this is delta T, okay, which is from T1 to T2, that's our temperature, over the total resistance. Alright? Yun yan. From point 1 to point 2, ang resistance ng overall is RT. Okay? But this is equal to every wall, no? Dahil yung ating Q or heat flow is the same on each layer. So, kung kukunin natin yung heat flow dito, which is Q, okay, it will be equal to this. So, how are we going to get the Q in our first wall? Okay? So, in our first wall, our delta T, because it's the same as this one, we are going to use this. Q is equal to delta T over R. But now we have Q1. So, what is our Q? Ang gagamitin nating formula ng Q1, it will be delta T1 over R, di ba? So, we have here delta T1 K over R1. So, dito sa Q2, it's the same. We have delta T2 over R2. Okay? And in our Q3, we have delta T3 over R3. Okay, so don't forget our R are the resistance, no? Yung mga R natin dito, which is this one, resistance, delta X, which is the thickness over K and over area. Okay, so now we have this. So what can we do about that? So first, identify natin yung delta T1 natin, no? Our delta T1 will be T1 minus TA dahil tandaan natin, this is from inside. So that means mas mataas yung temperature natin dito. So our delta T here will be T1 minus TA over our resistance 1. Now, for our Q2, we have TA minus TB over resistance 2. And for our delta 3, we have TB minus T2 over R3. Okay, and this is equal to the summation of delta T over RT. Okay, so now we need to simplify this. Okay, so I'm not going through the whole equation natin, no? Mapapahaba lang tayo sa derivation. But basically, what we need to do is to solve for this fraction. So, okay, so that we can combine this, and actually we are going to cancel our TA and TB in the long run in our equation. So at the end, we will have this equation. Our summation of delta T over RT will be equal to our temperature 1 minus temperature 2. Okay, so this is what we mean, temperature 1 minus temperature 2 over resistance 1 plus resistance 2 plus resistance 3. Okay, so this will be the equation na gagamitin natin for conduction in series, no? So, para maging mas malinaw din, summation of delta T over RT is equal to KT1 minus T2. What is our R1? Okay, we can use this one, no? We have delta X, our thickness, okay, of our wall 1, then our K1 A1, our area 1, then plus our thickness of wall 2 over K2 area 2 plus our delta X3 over K3 area 3. So basically yan din yun, ano? But medyo mahaba kasing equation to kung yan ang tatandaan natin. To simplify that, we introduce the resistance R. Kaya kung matatandaan ninyo, no, sa ating lecture about conduction, we told you to take note of this resistance R dahil mas madaling tandaan to, no? So you can apply this when you are studying for conduction in series. Now, to apply this, let us try to answer this problem here. So we have a composite wall consists of W1, which means wall 1, which is the outer layer, and W2, which is the inner layer. So W1 and W2 are both 5 inches thick. Okay, so inote na natin para hindi natin makalimutan. So our wall 1 and wall 2 are both 5 inches thick. So let us identify that this is wall 1 and this is wall 2. Okay, para identify na natin siya ngayon properly. Now, we know that W1 or our outer layer and W2 is our inner layer. So therefore, our direction is like this. Okay, because W2 is our inner layer and W1 is our outer layer. So our heat is coming from inside to outside dahil mas mataas ang temperature ng ating inside. Okay, so the thermal conductivity of W1, so given ang ating K, okay, for our W1. So our K for W1 is 1 BTU per feet R degree Fahrenheit. While for W2, we have K2 is 0.1. Okay, sorry, there is a mistake here. This is 0.1. Wala to, no? You'll get confused. Okay, so we have 0.1 BTU per R feet and degree Fahrenheit. Okay, so given ang ating thermal conductivity. Now, the temperature of the outer layer, so ang outer layer natin is itong W1. Okay, so given ang ating temperature dito. So our temperature in our outer layer is 500 degree Fahrenheit. And our temperature on the inner layer, which is our T2 here, is 1,500 degrees Fahrenheit. Okay? So, nakuha na natin lahat ng given natin. So, ano yung pinahanap? Ang pinahanap sa atin is yung Q total. So, yan ang kailangan nating ma-solve ngayon. So, we'll try to solve that now. So, tandaan natin, given din yung unit ng Q total, no? So, ang Q total should be expressed in BTU per R and feet squared. Okay, so yan yung unit ng ating Q total. Now, let us try to solve that. We only have two walls here, diba? So, our Q total is equal to the summation of delta T over RT. Okay, so since meron lang tayong dalawang wall, so that means we will have T2 minus T1 over R1 plus R2. Diba? And don't forget, dito sa ating equation, yung T2 natin is yung may mas mataas na temperature, diba? Alright, so we need to take note that our resistance is equal to delta X, which is our thickness, over K and area, right? So, basically, meron tayong R1 and R2 dito, so we have delta X1 over K1A1, diba? So, we can try to substitute that here. So, we have T2 minus T1. Okay, so we have delta X1 over K1A1 plus delta X2 over K2A2. Alright, so alam natin yung temperature. We can directly substitute that. We know the thickness because we have here 5 inches. Diba? So alam natin yan. We also know the thermal conductivity. We have given here K1 and K2. But, we do not know the area. So, ano yung area natin dito? So, basically, kung makikita ninyo yung ating required, okay, our required is to find the Q total in BTU per R per feet squared. So, we need to get the BTU per R for every 1 square feet ng ating wall. Okay, so basically, our answer should be based on 1 feet square area. So let us put that as our basis. Okay, so our basis here should be 1 feet squared of our wall. Okay, so basically dahil equal naman ang ating area dito, so our A1 and A2 will both be equal to 1 feet squared. Okay, so now let us substitute our given here. So we have our T2. Our T2 will be the one with higher temperature, which is 1,500 degree Fahrenheit. So we have 1,500 degree Fahrenheit minus our T2 here, which is 500 degree Fahrenheit. Okay, And then our delta x1, which is our thickness. So our thickness is 5 inches. So we have 5 inches, but we need to convert that into feet. So we have 12 inches to 1 feet over our K1. Our K1 is 1 BTU feet hour degree Fahrenheit. So 1 BTU foot hour degree Fahrenheit times our area 1, which is 1 feet squared, plus, okay, so dito naman tayo sa ating resistance 2. Our resistance 2, we have delta x. So our delta x is also 5 inches. So 5 inches, convert that into feet, we have 12 inches in 1 feet. Then our thermal conductivity in our second wall, which is 0.1. So we have 0.1 BTU, okay, BTU per feet R degree Fahrenheit times area, which is 1 feet squared. Okay? Alright, so let's check kung ano yung mga units na pwede nating i-cancel dito. So inches will be cancelled out, inches will be cancelled out. And in here, we have feet squared and feet. So, ang magiging unit natin dito, this will be cancelled out and we will have only 1 here. Okay, and we have only feet. But also, we also have 1 foot here. So, this will cancel out itong nasa denominator natin. So, this will be cancelled out and this will be cancelled out. Okay? Right, so solving for this, we will have now, for our numerator, we have 1,500 degree Fahrenheit minus 500 degree Fahrenheit. We have 1,000 degree Fahrenheit. Okay, so solving muna natin to, no? Para mas malinaw sa atin. We have 5 divided by 12, which is equal to 0.4167. Okay, so ano yung magiging unit natin? So don't be confused by our unit here, no? Because baka ang ilagay nyo is BTU per R degree Fahrenheit. Now, don't forget this is in the denominator, right? So it will be R degree Fahrenheit over BTU plus, okay? We can now solve this part. Okay, so we have 5 divided by 12 divided by 0.1. Okay, so we have 4.167 R degree Fahrenheit BTU. Okay, so simplifying this, we have 1,000 degree Fahrenheit. We can add itong nasa denominator natin, ano? So, we have 4.167 plus 0.4167. We have 4.583 R degree Fahrenheit BTU. So, now we can cancel out itong ating unit na degree Fahrenheit. Okay? So, let us try to solve this now. We have 1,000 divided by 4.583, we have 218.18. Okay, sorry, 218.18, and our unit will be BTU per R. Okay, but don't forget that our basis here is per 1 feet squared. So therefore, this will be for every 1 feet squared. Okay, of our wall. Okay, so that means our Q total will be this one. And this is our final answer for this problem. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.